Hello everybody, welcome to webinar of the keys to understanding neural network. In this webinar, we talk about the concept, classification, learning process, and application of the neural network. In our next webinar, we would like to talk about mixed reality in HoloLens. You can see in this link. I'm Diego Calvo. I have been working in machine learning for 5 years ago. Of the last 3 years, I have been working on my PhD on a topic neural network in health sector. I was previously working as a project manager of 8 years in a research and development project. Now I'm working in Brintia as technical lead in machine learning. Today, I will put the focus in the neural network to learning process to type and practical example. But before, we will do an introduction for machine learning with the aim of contextualize neural network in machine learning. Introduction machine learning. Before starting, I would like to contextualize neural network in machine learning. First, we can see the artificial intelligence cycle. Artificial intelligence is a learning technique to allow machine to imitate the human behavior. Machine learning is a subgroup that use statistic method to allow machine learning improve user experience. And final, deep learning is a subgroup to allow use of neural network. But what is machine learning? Machine learning is an analytic method to automatize learning of data, discover hidden patterns, and making decisions based on data. Classification of machine learning. Machine learning have two kinds of learning. The difference is that supervised learning needs to indicate level to calculate, and with unsupervised learning is not necessary. In supervised learning, we can find classification and regression methods, and in unsupervised learning, we can find clustering and dimensionality reduction. In all the kind of methods, we can apply neural network to resolve problems. Introduction neural network. Neural network is a paradigm of learning automatic processing inspired by the functionality of the human nervous system. Now we refresh the biological basic concept. The process starts when the dendrites capture information in the form of the signal. This information is processed by the soma, distributed by the axon, and sent to the next neuron by the axon terminals. Artificial network operation. In this graph, you can see now a neuron is simulated in the biological process. Now, we explain to behavior with a mathematical function. In the first part, we multiply the input by the heights. And in the next step, we calculate a balancing and the result that is applied to additional function. Activation function, sorry. Now we put the focus in the activation function. The activation function transforms the natural number in a delimited rank, normally 0 or 1. For example, 2 convert in 0.8 and 1 convert in 0.7. Neural network, neuron grouping. Of the behavior of the neuron is defined, a neural network is a grouping of neurons. In this structure, you can see hidden layers. The layer allow to representation of a non-linear function. In this layer, when the system continues learning, they are able to eliminate some links they don't consider relevant. This slide is the most important slide in the presentation because explain the keys to learning process. You can split the process in 3 parts. Forward propagation is a process for applying all hits and interconnection for input layer to output layer. Second, calculate of function cost. Calculate the difference between estimate cost and the real. And final, back propagation. Recalculate the height of the all neurons. Now, we will show step by step with an example. Let's imagine that what to predict final mark to know the partial mark a neural network. In the first step, multiply 8 by 0.5. I obtain the 7. When compare the result 7 with 8.4 as calculate the function cost. We can see that the result is not the same. For this reason, we recalculate the weight with a backpropagation process. In this case, the 0.5 convert in 0.4, and the other one in the contrary. In the second step, multiply 8 by 0.4, and in the backpropagation, estimate 6.8. It's not the real. For the reason, apply to backpropagation, and the next step is the same. Backpropagation, estimate the cost is not the real. This method apply a lot of times. This time is epochs. Now we put the focus in the learning rate. The learning ratio is the number that increasing or decreasing weight to each iteration. In the learning ratio is very slow. It takes a lot of time to convert. In the learning ratio is very fast. The function diverge and never will find the solution. For this reason, we will look the average learning ratio. This is correct. And the function is convergent. Neural network classification. We will now talk about the type of neural network according to their topology. There are four kinds of neural network: monolayer perceptron, multilayer perceptron, recurrent neural network, and convolutional neural network. The first, monolayer perceptron, is the most simple topology. It is used to predict linear function application. For example, estimate of a customer experience based to their incomes. We can see is a linear regression behavior. Multilayer perceptron is previously commented. It is network. The system is able to predict a nonlinear function thanks to the hidden layers. For example, predict the energy demand over time with respect occupation and date, for example, and is a nonlinear behavior. Recurrent neural network. This kind of network is very powerful to sequence analysis. The sequence can be sent with text, sound, and image. For example, we predict a lot of tests with Cervantes style, and the recurrent neural network be able to write new tests with a Cervantes style. Convolutional neural network. This kind of network is very powerful to image analysis. The convolutional neural network are composed of consecutive layers of convolution and pooling and finish with a multi-layer perceptron. This one, and the other one. In this slide, we can see the operation of convolutional neural network. In the first step, raster each frame of the image by moving n pixels per iteration. In the second step, we apply convolution to detect simple form, for example, lines, vector, or something. In the third step, we apply a pooling to reduce information. We repeat step sometime. We can detect feature, for example, pitch, hair, tail, and finally, is the picture have a pitch, a hair, and tail, we can say that it is a bird. In this graph, we can see the details mathematical operational convolutional operation. We multiply the part of input layer by use filter and obtain one value of convolution. The step of pooling is easy to understand. We put the focus in the orange zone as find the maximum number. Also, we can use other functions, for example, minimum, average, or something. Now we present two examples network. The first example is a convolutional neural network. In this example, we can see the behavior convolutional neural network. One second. I put the number to predict, for example, 5. In this case, you can see the convolutional layer. This one, this one, this one is a convolutional layer. No, and the other one is a pooling layer. For this reason, this convolutional neural network have two layers, this one and this one, to convolution, and two layers for pooling, this one and the other one. And finally, you can see a multi-layer neural network. This one, all the thing is connected. In the other one is the same, and the other one is the same. The second example, multi-layer neural network use Keras. Keras is a framework to develop a neural network. In this case, the convolutional network used to predict the production problem for the production in the lines and the priority that exists. For develop this layer, we need have analysis. In the first part, you can see for input variables. For this reason, the input layer is 4. And the other one, you can see only one variable, but two possible results, yes or no. For this reason, the output is two output layers. Now you can see the configuration. 1, 2, 3, 4. The input are 1, 2 output. Now I saw the code. In this code, I developed a convolutional neural network. In the first part, configuration and package. In the second part, load and data presentation. I would like to put the focus in this part because it's necessary to normalize the values of the variable predictor. When I have finished the load, it's necessary to define the model. And in define the model, if you remember, the final layer is 2. This one, you can see is the same. And the input layer is 4. This one is 4 because it's the number of columns. When I define the model, I compile the model. This sentence is necessary to compile the model. When I compile the model, the other step is training model. In training model, you can see that different parameters to the neural network. For example, sample data, dataset, branch rate, learning rate, number of epochs, visual parameters. Now I execute the code. In this part, we can see the two graphics. In the first part is the loss. It is the accumulation to the user. We can see that is reduced throughput the experiment. The smaller to better is will adjust our model. And the other one, the accuracy. Define the accuracy of the model. If you can see, the accuracy improves when the epoch is bigger. And it's possible to change the parameter. For example, the epoch is slower and ratio is bigger. With this parameter, with this configuration, the values of the exit is different. The idea is to change the parameter to improve the accuracy of the model. And with this explanation, I finish the demonstration. Thank you for your attention. I open your question. So, if no any question, I have finished the webinar. Thank you for your time.